Exploring the universe is a daunting task. There are often immense challenges that must be overcome before even setting out on a mission. The Ionospheric Connection Explorer, or ICON, has faced multiple barriers that have delayed its journey to study the frontier of space, the dynamic zone high in our atmosphere, where Earth's weather meets space weather. But before we can reap the benefits of its scientific research, ICON must launch successfully. The ICON team's can-do spirit will be repeatedly pushed to its limits while striving for a long-awaited and hard-earned T0.
A successful space launch requires flawless execution of a highly complex machine, and Pegasus ICON is no different. During previous attempts, we observed some anomalous readings. We worked through that with NASA and implemented corrective actions. This will ensure a highly successful mission.
Perseverance is doing something despite difficulty or delay in achieving success. It's a required virtue when the subject is spaceflight and the focus is a successful mission.
Just like any rocket, you have your share of problems that you run into, because this is rocket science after all.
Issues arose, but dedication never wavered. The entire ICON team knew this was about more than just rocket science. It was about the payload, science that would benefit all of humanity. As with every NASA program, giving up is never an option.
It has taken us months, hours, days to really resolve a lot of these issues with this integrated team. And thankfully, we were able to get through them, and here we are getting ready to launch.
The ionosphere is not only the area through which radio communications and GPS signals travel, it's also the space where many critical satellites and spacecraft orbit, including the space station that houses our astronauts. But despite the importance of this region, it is not well known. That's why NASA and the University of California, Berkeley built ICON.
The ionosphere itself, where ICON will be doing most of its work, is where the GPS signals travel through, it's where astronauts travel, and so it's very, very key for us to understand this region because it has profound effects on us here on Earth because of what space weather is doing to us, but it also gets profound effects of what our Earth weather is doing to the ionosphere.
By studying how the ionosphere reacts to Earth's atmosphere, it will help scientists and meteorologists forecast the conditions in our space environment, reducing its negative effects on our technology. From 360 miles above Earth, at a 27-degree inclination, ICON will sample ionospheric variations in the lower boundaries of space over the course of hours, days, seasons, and decades. Traveling at more than 4 miles per second, or about 30 times faster than a commercial airliner, this satellite will examine how the ionosphere reacts to our planet's weather.
The ionosphere is highly variable, more variable than we ever expected. Now we think that the answer to understanding the conditions in the ionosphere and being able to predict those conditions relies on our ability to understand how weather below is forcing space weather above. So ICON's built to capture all the information that we think we need to understand the mechanisms and the process by which our lower atmosphere affects our upper atmosphere.
ICON will be sent into orbit by a Northrop Grumman Pegasus XL air-launched rocket. The rocket has 3 solid propellant stages and can deploy satellites weighing up to 1,000 pounds into low Earth orbit.
We selected the Pegasus XL launch vehicle. It provided an excellent combination of mission performance and flexibility for the mission design for a spacecraft of the mass of ICON.
The launch of ICON will be anything but ordinary. It will be carried on the underbelly of Northrop Grumman's L-1011 Stargazer aircraft, a launch pad far above the clouds in the sky.
The one unique thing about Pegasus is that it's air-launched. So the L-1011, which is the last flying plane of its kind, it is essentially our launch pad in the air. It's a mobile launch pad that flies up to about 40,000 feet, and that's where we launch the Pegasus from.
With the tireless effort by the team to reach mission success, It is time for Icon to prepare for another launch attempt.
There are no constraints on the
For all
Icon.
involved, this is familiar territory, yet something feels different this time.
Taking a little extra time and extra care with the launch vehicle, but we're about there.
Why I'm excited right now is that we're getting so close to launch, and it has taken a huge effort to get there.
Vandenberg Air Force Base in California is bustling with activity. The excitement is palpable as Icon literally comes together. Pegasus stages 1, 2, and 3 are assembled. The aft, skirt, and fin installation are now complete. Icon's solar array illumination is tested. And finally, the spacecraft is mated to Pegasus.
Once it's mated to the rocket, there'll be a compatibility test between the rocket and the observatory. So the rocket will be the interface to communicate to Icon so we can command it. Once we certify that, we will encapsulate it. We'll put it on a transport platform, roll it out to the hot pad, and then integrate it to the L-1011.
Now that processing and mating are complete, the Icon mission takes off from Vandenberg. Hours later, it arrives at Cape Canaveral Air Force Station skid strip in Florida. Important logistics must be coordinated with the 45th Space Wing prior to launch. Once in Florida, there is a week of processing and testing prior to launch day. Lieutenant Samantha Parr is in charge of making sure Icon launches into a safe environment.
So I keep track of the weather, I keep track of our instrumentation, and I keep track of our surveillance. And I provide a recommendation to our launch decision authority, and he or she can make a determination on whether or not we're clear to launch.
We are now at launch day. The team has been here before, and optimism is guarded.
It's been a lot of work to get here. At this point, we kind of see the end, and we're looking forward to a mission and putting the satellite into orbit and seeing what that science does in the future.
Anticipation builds to a fever pitch. All systems are now go for launch.
The actual time parameters for a launch of a Pegasus mission is much different than your standard ground-based missile launch. That's tied to the fact that the Pegasus literally has a first stage by being on an airplane. The airplane's at 40,000 feet. It's moving close to 500 miles an hour. It's moving. You can't stop it. You can't slow it down. It is going, and it's dynamic.
The Stargazer jet takes off from the skid strip at the Cape Canaveral Air Force Station.
L-1011 is airborne at this time.
The L-1011 has now reached a cruising altitude of 40,000 feet and has begun flying in a racetrack pattern.
We fly a pattern called the racetrack. It's an oval in the sky, and so the airplane takes off, flies through the launch point at a lower altitude as it's climbing to the point we're going to launch at, which is roughly 40,000 feet.
We verify that all of our GPS are synchronized and ensure that we are going to put the launch vehicle in the correct heading so that we get the spacecraft into the correct orbit.
LC Peg, go for fin pin retract. LPO, go for fin pin retract and fin sweep.
LC, Senior Medco countdown, L-1011 is in the box.
About 50 miles offshore of Daytona Beach, the Pegasus XL is released from the L-1011.
With the countdown, we hear drop on my mark, 3, 2, 1, drop, and we push a button in the cockpit. The hydraulic releases actually release the rocket.
Pegasus away.
The rocket drops for 5 seconds, the airplane climbs for 5 seconds, and at the end we have a fairly good safety margin.
5 seconds later, the Pegasus rocket ignites.
Stage 1 ignition has been confirmed.
That's the minute that I consider T0 for me.
Soon after Pegasus ignites, first stage booster burnout and separation occurs.
Stage 1 separation confirmed. Stage 2 ignition has been confirmed and attitude is nominal.
Followed by fairing separation and second stage separation.
Fairing deployment has been confirmed.
After third stage separation, the ICON satellite is deployed into its lower Earth orbit.
Spacecraft separation from the Pegasus launch vehicle. So thank you, old friend, for doing that, and good luck, ICON.
It is a monumental moment for the entire ICON team, who banded together to overcome hurdle after hurdle. Powered by teamwork and unwavering dedication to its mission, ICON has overcome all obstacles in its path on the way to a successful T0.
Well, it's been quite a ride. It's been an incredible journey to get to this point and required the sacrifice of a very large team. We couldn't be more excited and honored to have launched the ICON spacecraft in orbit.
Great job for the team. Congratulations, ICON.